Welcome back to Olympus VFX, your go-to source for all things related to visual effects and real-time rendering. In today's tutorial, we're venturing into the exciting world of automotive simulations in Unreal Engine 5. I'll guide you, step by step, through the process of setting up car suspension to bring more realism and dynamics to your vehicle models. Whether you're a beginner looking to get started or an experienced developer seeking to refine your skills, this tutorial will provide valuable insights into creating stunning, physics-based animations in UE5. Stay tuned as we gear up to rev your project's engine to the next level. Before we get started, be sure to like, subscribe, and hit the notification bell on this channel. By doing so, you'll stay updated with my latest tutorials, tips, and tricks that will help you master Unreal Engine 5 and other VFX tools. I always appreciate your support, which motivates me to create more content tailored to your learning needs. Now, without further ado, let's jump into setting up car suspension in UE5 and take your automotive simulations to the next level. In this video, we will be expanding on the existing car rig we created in the previous videos. If you haven't watched those yet, I'll include a link in the description below. To begin, open your car control rig and navigate to the My Blueprint tab. Add a variable named Z offset RL target. Then, duplicate this variable 3 more times to have a total of 4. Rename each to match the respective wheel and set the type as float. We need to duplicate one of those variables and rename it as Z offset RL. Next, replicate this process 3 more times, totaling 4 duplicates, and rename each to its corresponding bone name. Let's create a function. Click on the plus to add a function and name it Wheel Trace function. Then select the entry node and in the detail panel, add an input and change the type to Rig Element Key. After that, add an output and modify the type to vector, renaming it to value. Expand the value pin and then right-click to locate Get Transform Bone. Connect the augment pin to the item pin. Locate the root bone in the rig hierarchy, drag it to the grid, and select Get Bone. Proceed by expanding the transform pin, dragging from the translation pin, and searching for Add. For the root bone transform, drag from the translation pin and search for the subtract node. Begin by selecting the drop-down options for pins, A and translation pin. Then, drag the root bone's Z pin and connect it to the Z pin of Add, A pin, and subtract, A pin. Next, link the X pin from the Get Transform to the X pin of Add A and subtract A and connect the Y pin to both Add A and subtract A. Expand the B pins next. Set Add Z to 10 temporarily and subtract Z to 30 to control the vertical wheel movement. Further adjustments will be made later. Then, right-click and insert a sphere trace node. Include 2 object types and change one to World Dynamic. Finally, connect the Add Result pin to the Start and the Subtract Result pin to the End pin. To determine the radius of the wheel, a simple method involves selecting the vehicle in the scene, switching to a side view, and drawing a line across the tire. After measuring the wheel to be approximately 70 units, input this value into the radius node within the rig control. Subsequently, expand the hit location and connect the Z pin from the hit location to the Z pin of the return node. Proceed by navigating to the forward solve section, then drag the wheel tire function into the grid. Modify the type to bone and change the name type to a calipers. Drag the corresponding Z offset target onto the grid, select Set, and expand the value pin. Connect the Z pin to the value pin of the set target and link the execute pins. Repeat these steps for the remaining 3 wheels. Finally, ensure all execute pins are interconnected as demonstrated. Next, Connect this to the sequence node by adding a pin and linking it to the wheel trace function. Retrieve all the Z offset targets, place them on the grid, and choose Get. Then, search for alpha interpolate by right-clicking. Connect one of the Z offset targets to the value pin. Proceed by placing the corresponding Z offset variable on the grid, select Sets, and link it to the result pin. Repeat these steps for the remaining 3 wheels. Change the interp speed increasing-decreasing to 20. Next, let's connect this to the sequence by adding a pin and linking it to set offset. Then, connect the other set offset pins and make sure to check the interp result box on all alpha nodes. Now, move on to the wheel rotation section. Drag the Z offset to the grid and choose Get. Open the translation pin on the offset transform node and link the value pin to the Z pin. Repeat these steps for the remaining 3 wheels, ensuring you connect the corresponding offset. Duplicate all 4 offset transform pins and rename them to break accordingly. Then link them to Execute. Duplicate, get offset, and link the value to the Z pin. Finally, compile and save. You should now be able to animate the cars seamlessly. At this stage, the outcome may not align with your expectations if your vehicle ends up resembling a monster truck unintentionally. Ensure the Z-axis is reset to 0 on the floor, camera rail, and car. Additionally, if your wheels exhibit excessive or insufficient vertical movement, adjust the values in the wheel trace function accordingly. The final step is to manually keyframe the body to synchronize its movement with the wheel going up and down. That concludes this video. Remember to like and subscribe to stay updated on upcoming content.